Hello friends, welcome to Daring Marina YouTube channel. Today we will be discussing about losses in transformer. We all know that an ideal transformer which is 100% efficient, but in reality nothing in the universe is perfect or ever ideal. Since output power of a transformer is never exactly equal to the input power, that means input will not be exactly equal to output. Due to number of electrical losses inside the core of windings of transformer, we will not be able to get 100% efficient transformer. So, we all know that transformer is a static device. So, we do not see any movement inside in its part. So, no mechanical chance of getting a mechanical loss is less. So, only electrical loss can be observed here. There are two types of electrical loss mainly. They are copper loss and iron loss. Other than this, some small amount of power loss can be formed in the form of stray losses also may be observed due to leakage of the magnetic flux. So, copper loss. These losses occur mainly in the windings of transformer when heat is dissipated due to current passing through it. So, some internal resistance mainly offered by the windings. These are also known as ohmic losses or I square R losses, where I is the current passing through winding, R is the internal resistance of the winding. These losses are present, can be seen both in the primary and secondary winding of a transformer depending upon the load attached to the secondary windings, since the current varies with the variation load. So, these are also known as variable losses. This can be found from the formula P ohmic means copper loss will be equal to, or ohmic loss will be equal to IPRP plus ISRS. IP means current in the first primary and resistance in the primary plus ISRS means secondary current plus secondary resistance. That's the formula. P ohmic will be equal to IPRP plus ISRS. IP primary current, secondary current, then primary resistance, secondary resistance. Iron loss. These losses occur mainly in the core of transformer, which are due to some variations in flux. This loss mainly depend upon magnetic property of material that which present in the core. So these are also known as iron loss. As a core of transformer, it is made of iron. So they do not change like load and load. So these losses are also constant. Like I mentioned, copper loss it is varying, but here this iron loss it is constant. There are two types of iron loss: eddy current loss and hysteresis loss. So eddy current loss, when an alternating current is supplied to primary windings of transformer, it will generate an alternating magnetic flux in windings. It will then induce the secondary winding through the Faraday's law of electromagnetic induction. Then it is transferred to externally conducted load. During this process, other conduction materials in which core is composed of get linked with the flux, and thus an EMF is induced in the process. But this magnetic flux does not contribute anything towards the externally conducted load. So, output power and is dissipated in the form of heat energy. Such loss is known as eddy current loss. Means when an alternating current supplied to primary winding of a transformer, and they will generate an alternating magnetic flux in windings, and it will get induced in the secondary winding, and due to Faraday's law of electromagnetic induction, and it will be transferred to the externally conducted load. So during this process, other conduction materials of the core will be composed of, and it will get linked to the flux, and thus an EMF is induced. But in the magnetic flux, that does not contribute to anything towards externally conducted load, or output power dissipated, and it will dissipate in the form of heat energy. So these losses are known as eddy current loss, and it can be expressed in the mathematical equation P equal to Ke F square Kf square Bm square. Here Ke will be equal to constant of eddy current, Kf square equal to a found constant, Bm will be equal to strength of magnetic field. P equal to Ke F square Kf square Bm square. So for mathematical expression for finding eddy current loss. Then hysteresis loss. It is defined as the electrical energy which is required to realign domains of ferromagnetic material present in the core of transformer. Means electrical energy required to realign domains of a ferromagnetic material. That's the thing of hysteresis loss. These domains lose their alignment when alternating current is applied to primary windings of transformer, and EMF is induced in the ferromagnetic material, which disturbs the alignment of domains, and afterwards it will be difficult for them to realign. For the proper realignment, some external energy is supplied in the form of current, and this extra energy is known as hysteresis loss. Like I mentioned, these domains will lose their alignment when alternating current is supplied in the primary windings. So, as EMF is induced in the ferromagnetic material of the core, that also will disturb the alignment of the domains. Afterwards, it is very difficult to realign the domain. So, some external energy is required to make it proper alignment. So, this energy loss is known as hysteresis loss. It can be found out from the formula pH equal to kH into Bm power 1.6 FV. pH equal to kH into Bm power 1.6 FV. Thank you.